In this section, we're going to be looking at solving radical equations, which just simply means that your equation is going to have a radical sign in it. And the ones that we're going to look at, the radicals are all going to be square roots, but you could also have cube roots, fourth roots, and so on. So here's just a little bit of an explanation of the process that you're going to go through in solving this type of equation. As it states, to solve a radical equation, you need to isolate the radical on one side by itself and then raise each side to a power suggested by the index. Now, if you remember, your index is the little number that you have right here that in an earlier section was referred to just as n, just in general. And since we're going to be looking at all square roots, then the number that we're going to have here is going to be an understood 2, which means when I go to raise each side to a power, I'm going to be raising each side to the second power. If it were a cube root, you're going to raise each side, to the third power, and so on. All right, the last little paragraph here, it says when you raise each side of an equation to a power, it is possible to introduce extraneous solutions. That just simply means solutions that will not check. And so therefore, that means once we're finished solving these equations, we are going to have to substitute our possible answers back into the equation and make sure that they do check. All right, the first one that we're going to look at. Now, as the steps stated, or that first paragraph stated, you need to have your radical on one side by itself. So I need to get the square root of 2x minus 3 by itself, which means I need to subtract my 3. Okay, so if I subtract my 3, then I'll, on the left-hand side, we'll just have the radical, the 2x minus 3. And of course, if we're subtracting 3 on this side, then that's going to give me equal to 5. All right, so now this is a square root, as I had stated, so that means that we're going to square both sides. Okay, so on the left, when you square a square root, you're just going to simply be left with what is underneath, and that's something that was discussed earlier in the course. Basically, just like adding and subtracting undo each other, a square root and raising something to the second power or squaring something, those processes will undo each other. Okay, then you'll have to also square your 5, which is going to give you 25. Now at this point you have just a very basic equation to solve. You would need to add the 3. So I would have 2x is equal to 28, and then you've got to divide by 2. So the 28 divided by 2 is going to give you 14. Now, as I stated, you've got to check this, and this is not something that you have to show me. You can just check it in your head, check it on a piece of paper, check it in your calculator. So if you have a calculator handy, that's perfectly okay. I'll just do it over here to the side, and this is what you would have to do if you didn't have a calculator to assist you in this. But just take your 14 and plug it back in. So you would have 3 plus the square root of 2 times 14 minus 3. Of course, that's supposed to be equal to 8. All right, so now let's simplify what we have here on the left. So you do your 2 times your 14, so that's going to give you 28. And then do your 28 minus your 3, which is 25. And then do your square root of 25, which is 5, and now finally do your addition, and you do get 8 equals 8. It does check, therefore 14 is your answer. Majority of the time, these will always check, but you have those few instances where they don't, so make sure that you do always double check. The next example that we're going to look at. Now this one already has the radical isolated on one side by itself, so you're ready on this example to go ahead and raise each side to a power. So that means we're going to raise each side to a second power, because again this is a square root. That's why we know to do the second power. Okay, so on the left, you square the square root. Remember, that means that you're just left with what's underneath. Now, this one's going to have a little bit more work to it because on the right-hand side, you have a binomial. And if you have a binomial you've got to square, then that means you have to write it down twice and you have to FOIL it out. Okay, so using the FOIL method here on the right, I would have x squared minus x plus 1. Now, what I'm left with at this point is a quadratic equation. Of course, I know that because of this term being to the second power. We studied quadratics back earlier. So you do need to have your equation set equal to 0. So in order to get 0 on that left-hand side, that means I've got to subtract the 3x and subtract the 7. So what I would have at this point would be x squared minus 5x. If you combine all your x's here, you'll have a negative 5x, and then the 1 minus the 7 will give you negative 6. And this is going to factor. Let's see, you will need to use 6 times 1. And in order to get your negative 5, you need a negative 6 and a positive 1. Therefore, you get x is equal to 6 and x is equal to negative 1. Now, again, you will have to check each one of these. So just starting with the 6 and plugging it in. The 6, I'm just doing this in my head real quickly. The 6 is going to check. Now let's see about the negative 1. Now the negative 1 is not going to check, okay? Let me just kind of show you here to the side real quick. You would have the square root of 3 times negative 1 plus 7, and that would be equal to negative 1 minus 1. Okay, so underneath your radical, this would be negative 3 plus 7, which is a positive 4. And then square root of 4 is 2. So what happens is on this one, this doesn't check because you have a positive 2 equal to a negative 2. So what you would need to do in that case is make sure that you for sure X it out. Just put an X through it if it does not check whenever you substitute it back in.